Welcome. This is Virgo Arbitrage. We are in lecture 2. My name is Miguel and let's get started. But before to start, I give you a quick summary of what we have reviewed as of now. In the introduction, I presented a quick summary of all the lectures. In lecture 1, we talk about finance and financial economics. Some key concepts that you have to deep dive in order to understand why markets are chaotic, why there are fluctuations, etc. And why economic policies are important to understand markets. Now in this lecture, we will review some more applied concepts to Virgo, like statistics and mathematics. Let's get started. Okay. Why this lecture is important? We will talk about this topic in this lecture. Why is it important to know mathematics, statistics, and some key concept of machine learning? I'm gonna do it as simple as possible so that people who is not technical can understand that. We will talk about fundamentals of probability distributions, some descriptive statistics, machine learning applied to Virgo, and time series. Why is this lecture important? Now let's start with the fun part. Data, numbers, indicators, metrics, mathematics, statistics, trends going up, trends going down, cycles, uncertainty, risk, etc., etc. If you are already in this field, you realize that it's hard. You have to be very critical of the decisions you are taking. If you are new, this is good for you because the goal of this lecture is to help you to understand or to help you to get critical thinking. Because you will have lot of things, and maybe it's not necessary to take into consideration all of them. You have to go maybe one by one, test them, try them, and build some confidence. Because if we put all the metrics, all the numbers in one place, by the end of the day, we don't get anything. It's the way it is, because it's too much to assess, it's too complex. It's better to keep it simple, to find things that work for us. And the only thing that help us to build this knowledge, to build this confidence, and build this, let's say, intuition, it's critical thinking and trial and errors. I like to have the following questions when I do my studies about markets, or I want to learn new topics that can help me to become a better trader or investor. Is why is it good? Is it a good decision that I'm gonna taking? Is it good the following stock I am analyzing? Is it good enough to take the decision now? And one way to assess that is to check in the past, to see whether in the past the same decision under the same logics worked, and count, for example, how many times it went good and how many times it went wrong. So at least this creates some confidence and understanding of my decision. Another thing is what if, to create some scenarios. What if the market is gonna go wrong tomorrow? What if the market is gonna go well tomorrow? So this helped me to understand, okay, or to build scenarios and what are gonna be my actions in each scenario. If it goes well, what are gonna be my decision? How, let's say, if it goes well, I can be more aggressive, or maybe I have to check other options, diversify more, etc. Or if it goes wrong, maybe it's better to do nothing and wait until the market stabilizes. Or what if the market is already stabilized? Do I have to buy more? Do I have to buy less? Do I have to check for crypto, etc., etc.? Is there any other option? Statistics help us to do so. In the first lecture, I talk about diversification and why it's very important to build a diversified portfolio. Maybe the market is going good now, and we want to look for, let's say, other options that maybe are not so profitable now, but maybe later. So I can put my money there. Let's see what happens if I do this action. Or maybe we are trying to put our money in different kind of markets. Let's say in the US, in France, or in Germany. How much of money I want to put in each of them, and in order to reach to this decision or to materialize the amount of money I wanna put in each place, it's statistical analysis. And the final question is it the right time? A lot of traders and investors try to find cheap price in order to sell high, but most of the time this is very hard or almost impossible to reach, to find the minimum price and to resell it in the high price. Normally we try to match trends. I am in a solid upward trend so that I can buy, or do I am in a solid bear trend, downward trend, so that I don't have to do anything, I don't have to risk, so I wait. So those analyses come up thanks to statistical analysis and a lot of critical thinking. Fundamentals of probability. Let's start with discrete probability. A discrete event is a countable and finite event. For example, a coin flipping whose outcomes are going to be 1 and 0, or a dice rolling whose outcomes are going to be from 1 to 6, or can be a modified dice, let's say 20 faces, 8 faces, etc. We have also more complex events. For example, we have an online platform and we have an online transaction. Is this transaction legitimate or is fraudulent? So in this case, we have two possible outcomes: fraudulent transaction, non-fraudulent transaction. In order to understand the probability of discrete events, you have in front of you two examples. The first one is a coin flipping. We have two possible outcomes, head and tails, and our event of interest is going to be the heads. So we want to assess the probability to get a head. We already know that a coin has two heads, so we expect to have 50%, 1.5 probability to get heads. So let's try it. Let's experiment. We flip 4 times and we get just 1 head. What happened? So in this experiment, we are gonna sum the number of heads, we get just 1, between the total number of trials, 4. In this case is 25%. So what happened? We expected 50%, but we got 25%. Maybe if we continue doing this experiment, we are gonna reach 50% at any point, but never 50% exactly. Or maybe yes. But we tend to this expectation. Because in real life, if you go further, make a lot of experiments, you're gonna tend to your expected probability. Now let's see dice rolling. We have 6 possible outcomes, and what is our event of interest? Let's take a range to make it simple. Let's take numbers from 1 and 2. We do 5 trials, and we get 1, 3, 6, 2. So we are interested in events at 1 and 2. So we have 3 good trials out of 5. So in theory, we expected 2 out of 6, which means 1 and 2 out of the 6 possible outcomes of the dice. Let's say 1/3. But when we did this experiment, we got 3 good results out of 5, which is higher than 50%. What happened? What happened? Previous example was less than 50%. Our expectation was less than 50%, but in this trial we got higher than 50%. Maybe if we continue doing this exercise, we will see that our probability is gonna start to go down. What is the key idea of both examples is to show you that there might be some lag. So we have to continue repeating the experiment in order to reach or to tend to the actual to the actual expectation. Let's visualize that. For the coin flipping, we can use a donut plot. Quite delicious donuts. I like it a lot. So we see here, the blue part is the probability of heads, and the orange part is the probability to get tails. Here we see the numbers: 25% for heads, 75% for tails. For the dice rolling, the way to visualize that is a little bit different. We got from the previous example, we have 6 numbers for the 6 faces for our dice. We got 1 event from number 1, 2 results for number 2, 1 event for number 3, and finally 1 event for number 6. And the way to visualize this is using a bar plot. Now it's time to talk about continuous probability. A continuous event is an event that is uncountable and tends to be infinite. For example, the measurement, size measurement in meters, then can be in centimeters, then millimeters, etc., etc. Another event is time. For example, we have time in hours, then in minutes, seconds, milliseconds, etc. Money can be a continuous event. We have dollars and then cents, and cents in different amounts. For example, in foreign exchange, we have a round part, and then the decimals can reach up to 4 digits normally, but some traders can reach up to 8 numbers in the decimal part. To understand better how to analyze discrete events, let's take the following example. We want to analyze the height of our classmates, and our event of interest is going to be how many students have higher than 1.80 m size, but there is a problem when we want to analyze continuous events. It's very difficult to get a very precise measurement of a given measurement. For example, what is the probability of to get one person who measures exactly 1 meter 80 out of my my classroom or my sample size. Maybe it's gonna be just one person. Yeah, and this analysis is meaningless. If we take ranges, the thing is gonna be more meaningful and more understandable. For example, we want to analyze how many people is higher than 1 meter 80 or lower than 1 meter 80. In that sense, we will have more matches, more observations, more events of interest, so that we can compute some probabilities. And another spectrum for analysis is a range. For example, how many people we have between 1 meter 60 and 1 meter 80. So in this interval, we will get some persons who will match this interval, and therefore we will have some insights. Let's say that we take some measurements of this for this experiment. We take the size of, let's say, for 30 people, and in order to analyze that, we use the following plot, which is a histogram. A histogram will show us the density of all the measurements that we just have taken. Some properties of histogram: we have tails, where we have tails on right, tails on the left, most of the time, where we will see the lowest concentrations, and a part that have the highest concentration, that normally is the center. For example, in our from our previous example, we have that people from 120 meters to 130, we just have two observations. The bar there is low, and people on the left who are very tall, people higher than 170 meters, we don't have not too many, and most of the classroom concentrates around 150. I forget. The histogram has two or three main parts. We have on the x-axis the measurement, and on the y-axis the probability or the density size. And then we have the bars. The bars are gonna measure for a given mean or interval how much of density we have. Now let's talk about descriptive statistics, and let's use our previous example. From our previous example, we got this plot on the right, and we want to get some insights. And those insights are gonna be inferred from descriptive statistics. We have many descriptive statistics, some very popular, like the mean, which is the sum of all of our observation between the number of observations. Quite simple. Then we have standard deviation. This is gonna be trickier to understand later with the section of risk. We will depict this concept further, but standard deviation in general will show us how dispersed is the data from the mean. Higher the standard deviation means that the data is dispersed. For example, if from our previous example, if we have a high standard deviation, means that maybe the concentration is from 130 to 170, meaning that people is not so concentrated around 150. But if the standard deviation is low, this can mean that people is very concentrated around the mean. Let's say that people has in general a high measure around 150. Then we have other popular and more robust descriptive statistics like median and quantiles. Median is more robust mean. Median is gonna take the central point to make it simple, and quantile is gonna take the quantile 25, a quantile 75, which means 25%, 75%, and take the range. Why we take quantiles? Because sometimes we have a concept called outlier. Outliers are, let's say, observations that are far away from the central mean or the central point. What is the goal of all of that? Is to make predictions. And we want to assess the following question. What is our expected size if we are gonna see, for example, a new class? So we want to predict that. And so thanks to that question, we will get into fundamentals of machine learning. Fundamentals of machine learning. The goal of machine learning is to make predictions. And to make predictions, let's say a machine learning model is an object that is going to learn from data, is going to be trained based on data, and based on those inferences or those insights, is going to apply this knowledge to new data, and then this object is going to make predictions or inferences. But to have this prediction, we have to set a very precise question. For example, is my my soccer team win the next match? Quite precise question. We have a subject, we have what we want to analyze or what we want to predict, and we have some context. So for a machine learning can learn that, we can take information from the past. For example, we can take how many matches my team won during the season, against which teams it won, whether some key football players I'm gonna be in the next match. So we can put all this together and make our prediction. So what a machine learning is gonna do is learn from this data which results were good, which results went bad, and then apply to the next match, and therefore make a prediction. Not so complicated if we see it in that way. We have two kinds of machine learning. We have first classification. Classification is going to be applied to discrete events or binary events like coin flipping, win or lose, or multi-class events. For example, predict whether a flower corresponds to a given species, or to predict whether an object corresponds to a specific category. For example, in financial markets, we can apply a model so that it can predict whether the market is in a bull state or in a bear state, or is it in a state which is uncertain. Then we have regression. Regression is applied for continuous events and is gonna try to guess the mean or the median result. For example, a good question is, what is the value of my car? There are some platforms or some solutions that try to, you take a photo of your car, you want to sell it online, and this artificial intelligence is gonna guess the price of your car given a photo. Or for example, give you another example applied to crypto market. What is gonna be the price of Bitcoin in the following week? Now that we know what is a machine learning model, we have the following question. How good is a machine learning model? How can we know that a machine learning model is going to give us accurate predictions? So, depending on the problem, we have metrics. For example, let's start with classification, the classification problem. where our goal is to predict true and false, 1 and 0. We have on the right side a matrix. This matrix is called confusion matrix, and there we crossed the predicted classes and the true classes. On the green box we have the true positives and the true negatives, the predictions that were correctly given, and then we have the red boxes where we have the mistakes. To make it simple, let's focus on two metrics for classification. One is precision and another one is recall. Let's say that we have an artificial intelligence that is going to predict the results of our team in the following matches. So the first match, it predicts that it's going to win, then it's going to lose, then it's going to win 4 matches in a row, and finally it's going to lose. But in real life, we got the following result. It loses in the 2 first matches, then it won in the 2 first matches, then it's lost, then won twice, and finally it lost twice. If we put those results in a matrix, we have 3 true positives, 1 true negative, 2 true false positives, and 1 false negative. So in order to calculate the precision, it's very simple. We take the true positive results, the true or the ones predictions that were correctly predicted, between the total or the sum of the total predictions, which is 5, which is the true positives and the false positives. The result of that is 60%. Not so bad. It's higher than 50%. We can rely on this model in terms of precision. Now let's see recall. Before passing to recall, I would like to give a simple concept of precision. We can think about precision as how accurate is gonna be the predictions of our model. Higher the precision, it means that the predictions of our model are gonna be more accurate. On the other side, recall means how much our model is gonna remember from the data, so that it's gonna give us many predictions. For example, for this case, recall, which is its formula, it's the true positives between the true number of classes. The true number of classes is the 3 plus 1 of the false negative, and the end result is 75%. 75% is a good number. So in terms of recall, our model is doing well. So we can conclude, conclude that this model is performing well, so we can rely on it. Here I would like to mention too that precision, there is a trade-off between precision and recall, because sometimes when models have high precision, they tend to have low recall, because we are demanding the model to have very, very high good predictions, but in detriment of that, it's gonna reduce the number of predictions that it's gonna give us. So maybe we will see that in life when we will jump into the Virgo panel, where we will play a lot with precision and recall, and how balancing both metrics we are gonna take actual decisions for investing. So let's go to the next slide, which is regression. Regression is trickier because we are talking about a continuous event and how a model is gonna behave on those kind of events. Let's say that we have second-hand car app. The app is gonna assess a photo of a car and then it give us a price. let's say we post 4 images. The first image, this app predicted 10K for the first photo, and the actual price was 9K. The distance is 1K, which is not so bad. What we have to mention here is that for regression, what is important is to keep the actual value of an event as closer as possible to the prediction. So closer it is, better the performance of the model. So 1K in this example is not so bad. Let's say another example for the second case is 15K the prediction, and the actual value was 18K. The distance is 3K, so not bad again. Let's have another one. 10K the prediction, and the actual value was 21K. The distance is 11K, so it's very far. So the prediction was wrong in this case. And finally, we have 20K prediction and actual value 9K. The distance is minus 11K. Bad prediction. So if we see those results, we see that we have a model that is not performing so well. Sometimes it gives us very accurate or very near predictions, or sometimes it gives us very, very high, very wrong predictions. So in order to assess that, we can take averages and decide for the model that has the lowest average, which means it has, in average, the lowest distance from prediction and actual value. Time series have 3 main components: trend, seasonality, and noise. Trend is whether the difference from the current value of our event is positive, negative, or zero with respect to previous observations. For example, in a stock market, a positive trend means that the price today is higher than the price of yesterday and the price of some days ago. A downward trend means that the difference price is negative in many days in a row. Seasonality is a pattern that repeats from time to time or from a window to window. For example, a seasonality can be seasons of the year. The temperature fluctuates. We know that in summer it goes up, temperatures goes up, and in winter it goes down, and it repeats every year. And noise is just the deviation from the mean and from the seasonality. What we can do with the time series? Well, we can do forecasting. We are gonna learn how the trend works, how the seasonality works, and then we are gonna guess what's gonna happen in the future. We can do some extrapolation of the trend and of the seasonality, and therefore we will get the future value. Example given, popcorn sales. We know that popcorn sales in weekends is high, and in Monday the sales of popcorn is low. So we can expect for the coming weeks to produce more popcorn in the weekends because people go more to cinema, while in Mondays we can reduce this production because people don't tend to go too much on Mondays to a cinema. So that's it for this lecture. Hope you enjoyed. I'm gonna share with you some extra videos. I know this is complex. This is hard to understand. If you are new to statistical concepts, don't be afraid. I'm gonna share some extra material so that you can understand further and deep dive into those concepts, and see you in the fun part, which we are gonna explore the app, and have a nice day. Good learning and good trading. Bye.